to se nevěděl. Tak to je posun. No?
Good afternoon, welcome to the seminar. Today's speaker is Koutecký from the Charles University, and he will tell us something about liquid democracy.
Okay, thank you very much for having me. It's a pleasure to be here. So I'll talk about fine-grained liquid democracy for cumulative ballots, but you can think about participatory budgeting to begin with. So I'll describe what these three things mean. This is joint work with Nimrod Talmon from Ben Gurion University, Beersheva, Israel, Krzysztof Sornat from ITSIA, Lugano, and Matthias Keppe from UC Davis. So I'll describe what is participatory budgeting for our purposes, liquid democracy, and then what do I mean by fine-grained liquid democracy. Okay, so in participatory budgeting, I have a set of voters. I will have n voters and a set of projects. I'll denote them C because more generally you can think of these as candidates. And so I have m of these. And the voters cast cumulative ballots. So an example that you can consider is that the projects I'm considering are to build a new high school, to extend a university, to do some repairs at a hospital, or to build a new birth center. And so, you know, the idea is that local governments are interested in what the citizens think, and they want to learn what they think, and based on this distribute a part of the budget, which actually happens. There's a very interesting recent paper, I think at HKI on participatory budgeting, mainly in Poland. There's, I think, a law in Poland which says that cities over some threshold, something like 10,000 or 50,000 people, have to spend at least, I think, 2% of their budget based on participatory budgeting, but they don't prescribe exactly you know, how to evaluate. So they don't prescribe what the ballots should look like and how the ballots should be evaluated. So actually what this paper does is it compares you know, the various systems and their social welfare and so on. So anyway, this is like this is not just a theory, it actually happens, and so people are interested in this. And so a cumulative ballot is just a vector of reals between 0 and 1, which sums up to 1. In other words, it's a point from the simplex. So let's say that my vote would be 0.1, 0.2, 0.3, 0.4, which means, for example, that I'm proposing to dedicate 10% of the overall budget, which is to be distributed, to the university. Okay, so the 0.1 means give 10% of the total budget to the university project, give 20% to the, sorry, 10%, okay, 10% to the high school project, 20% to the university, and so on and so on. Okay? So before I continue, I wanted to say one thing. So this talk will not be very technical, and so I would really like all of you to follow. And so you will do me a favor if you stop me, if you stop following. So I kindly ask you to stop me when something is unclear. This is mainly conceptual work, not so much technical. So it should be possible, hopefully, to follow. Okay, so Xij is what proportion of budget the voter J dedicates to project I. Okay, Oh, okay. So the set of all votes, the set of all ballots, you can think of it as an m by n matrix, right? Each voter gives this m-dimensional vector, and you have n of these. Okay, so that's where xij comes from. So this is participatory budgeting, and then it's a whole area where you think about, how to, based on this, select projects, because you can't just fund the university project, for 70% of its cost. Usually projects either have to be funded or not funded. It's a binary decision. And then you have voting rules which decide what to fund, what to not fund, and you can discuss what maximizes social welfare or what kind of social welfare and what not. But that's not what I'm interested in today. I'm only interested in actually eliciting votes. So in direct voting, this would be the ballots, and then how to process them, that would be the voting rule. I'm not dealing with that. Okay, what is liquid democracy? So this is actually a very simple idea. In liquid democracy, each voter has a choice between either casting their vote directly or delegating their vote to another voter, the delegate. So, let's say that I think that Tomáš is an expert. He has a better idea of how to spend the funds. And so instead of saying how I should split the funds, I just give my vote to Tomáš, and now he has 2 votes. Okay, so you can apply this idea to anywhere, not just participatory budgeting, right? So for example, if you have political voting with ordinal ballots, that's where you rank candidates, first, second, third, and so on. You can also use this idea there. Basically, in any voting, you can use the liquid democracy idea. And the obvious possible problem with this is delegation cycles, right? So maybe Tomáš decides to delegate his vote to Jakub, and Jakub delegates his vote to me, and then what should happen? So this is unclear. And so that's kind of where the area of liquid democracy comes in. And I will be also interested in that, but there's one more twist, and this is what we call fine-grained liquid democracy. And the idea is this. So maybe I really trust Tomáš regarding his views on education, but I don't think he's a healthcare expert, and I think that Jakub maybe is a healthcare expert. So I want to, delegate my decision on the first 2 projects to Tomáš, but I want to delegate my decision on the second 2 projects to Jakub. Okay, so it's not as simple as I have to choose one expert for all the projects. So this is what we would like to do. So formally, the voting process would be something like this. Each voter partitions the project. Okay, so I have SV, which is a partition of the set C, partition of the project. And now for each part, so subset of projects, specifies what proportion of the budget should be given to this bundle. So these S are, I will call them bundles. Okay, so how much of the budget to give to this bundle of projects, and who is the delegate to decide this. Okay, and we still allow direct voting simply by, if the bundle is of size 1, then the budget which I give to this bundle is simply my vote for this project, right? So this still, and I would set the delegate to be me. Okay, so this still allows direct voting. If you want to just cast your vote, you would decide for each project how much support to give, and this would be modeled by saying that the partition is just a partition into singletons, and I'm the delegate for all of these. Okay. We got some criticism that this is like this is impossible and people would never use this, it's too complicated. So we tried to do a kind of a UI mockup. I hope that this might convince you that this is not completely unreasonably complicated. So let's say that the voting platform would look something like this. You would have the set of projects at the top, and then you can drag and drop the projects to the rows below. This is where you create the bundles. And so maybe the user drag and dropped kindergarten and STEM education focus. This would be some kind of education program as the first bundle, gave it the name education, and said, give 25% of the budget to these projects, and I'm delegating this to a user named John Educated. And then there are some other projects, addiction prevention, social housing, community center. I'm giving 50% of these and delegating it to someone else, and so on. Right? So this is the idea of what the voting could look like. And I want to point out here, this is also a point of confusion often. I'm not saying that there is some global partition of the projects into educational, healthcare, and so on. The partition is per voter, right? So each voter decides, I want to take these projects and delegate that choice to that voter, and I want to take these other projects and delegate to that voter. The partition can be different for any voter. Okay, so this is what we propose. This is how we propose to make the liquid democracy fine-grained. And again, the question is how to resolve delegation cycles. Okay. So this is not a technical question. This is a conceptual question. What should be the criterion? How should I say that? What does it mean that some assignment or some completion of votes respects the delegations, right? So if I say, for example, that I want to spend 40% of the budget on the project school and university, and then let's say I know what Tomáš says about these projects. What does it mean that, what should be my choice to say that this is, the delegation was respected? This is not obvious, as I will hopefully show you. And somehow the first thing which came to our minds is what we call exact proportionality. So the idea is as follows. So let's say that, I decide 60% should go to the educational projects and 40% should go to the healthcare projects. And let's say that the educational expert says give 0.1 and 0.2 to the first two projects, the high school and the university. Okay. And the healthcare expert says give half and half to the two healthcare related projects. Then what we call exact proportionality would say, well, give, 0.2, 0.4 to the educational project. Why? Well, I need to divide 0.6 of support, and the ratio of the educational expert between the projects is 1 to 2. So the way to preserve this ratio is if I vote 0.2, 0.4, right? Because this will have exactly the same ratios between the projects in the bundle as the expert says. Okay, so this is what we call exact proportionality, because the proportions of the projects within the bundle are preserved. And then, same, if the healthcare expert says it should be 1 to 1 between the healthcare projects, then I would give 0.2, 0.2. Right? So this seems natural and straightforward. So literally, so if the okay, and here comes the tricky part, right? So in the definition here, I said if the delegate gives non-zero support to the bundle Fs, right? So if I say give 60% of the budget to the educational project, and I delegate it to Tomáš, and Tomáš, for some mysterious reason, says don't support education at all, what should I do? Does anyone have an answer? Use your own choice. Right, okay, so we will get to that. So let's say that I had, for every bundle, some default vote, which is, what I would do if, if I really had to put down my choice, this is what I would do. To not complicate the voting process too much, so not to ask, not to overwhelm the voter with your questions, maybe you can even like set some kind of a default for the voter. So maybe it would be even split. So just split it evenly between the projects, something like this. But you have to define some default. Okay, so this is a very reasonable choice. What we can show is if we don't yet define any defaults, but we say the following: if the support of the delegate is non-zero, then do proportionately to the delegate. Otherwise, any solution is fine. Okay, that's the other option. Basically, these are the two options. The first one is, you know, you have your default. This is what you should do if the delegate doesn't contribute anything. The other choice is you're happy with anything. So our result is the delegations can always be resolved if you allow yourself to do anything if the delegate gives nothing to this bundle. Okay. But this might be undesirable, right? Because it's kind of like, you know, you're saying I want to behave according to this expert, and as long as the expert gives some even, you know, minute amount of the budget to these projects, then you like completely obey their choice. But the minute they switch to zero, your vote can, you know, shoot somewhere completely different. And this is somehow weird to us. We think that this would probably not be a great, you know, voting system because it would be non-intuitive and somehow weird. But what we can show is, okay, if this is how you define the behavior, then a resolution always exists. Okay. I'll get to explaining why. Some of you might already see this, but okay. So now, if we want to somehow fix this weirdness, what we introduce is EP with thresholds, so exact proportionality with thresholds. So additionally, we have each voter define a default vector, and maybe if they, you know, if they don't want to define it, then it would be something like even split or, you know, something that the system defines for them. And then we want them to define delegation weights, which is somehow like my confidence in the delegate, something like this. And then using these, we define epsilons, which is just 1 over the delegation weight. Okay, so epsilon will be my threshold. You will see soon why I'm defining it as a weight, but for now you can think about epsilon as the threshold. And then EPT, this rule, is just if the delegate gives more than the threshold, then do proportionately to them. If they give less or equal to this threshold, then do the default action. Okay? The problem with this is the discontinuity at epsilon. Right? So this can completely change once you like move over the epsilon, and this actually leads to there are instances where there is no delegation resolution. So there is no way to resolve the delegations to obey this EPT rule. Right? So far, you all follow? Okay. Thank you. So their preferences over the bundles. But there can be multiple people delegating to. So first off, there are like no distinguished experts, right? The situation we're dealing with are cycles. So if there is, if the delegation graph is a DAG, directed acyclic graph, then you can just resolve it by starting from the sinks and working backwards, and there's no issue. So the problem is when you, okay, so they're just voters, but we, you know, in the literature you would call experts the voters that many people delegate to. But the situation we're dealing with is when there are cycles, which means that the experts also delegate, right? So their vote is not complete. So that's one problem. The other problem is that there could be multiple people delegating to one expert, and these multiple people have different partitions into bundles. And so what would it mean to normalize? Can you see the problem? Yes. You don't see or you see?
I don't see whether it's impossible, but I see
Uh-huh.
there could be breakpoints, but I don't know whether they're insert.
Well, okay, so maybe you know, so if the expert says okay, so let's say the expert says, you know, 0.1, 0.2, 0.3, 0.4, and this is the division into bundles, and so you're saying that I should somehow normalize this so that the bundles sum up to 1? So then, like, okay, now I have chosen the wrong numbers, but you would want to blow this up so that it sums up to 1, and this so that it sums up to 1? Okay, so the first problem is that then their ballot wouldn't be a cumulative ballot, right? Their ballot should sum up to 1. That's one problem. But the other problem is, what if? So this is the partition of. So there's a voter V which delegates to the delegate, but then there's a voter U which delegates, and they put these 3 projects into a bundle. And so if you normalize these 2, like you cannot normalize simultaneously these 2 and these 3, no?
No, you can normalize at the time of the use in the bundle. So sort of, let's constrain the expert.
Okay.
Let's say he assigns like non-zero sort of valuation or
Ah,
to all of the projects within his competence or something, right? And
right.
sort of whoever sort of
Right, right, right.
asks him to provide an opinion on
Right.
a bundle, which
Yes.
is a subset of what he feels is within his competence.
Right, right, right. So, no, so
Normalize the valuation in the bundle.
sure.
Comes up to 1,
Right.
and then
So yes, yeah. So like
resolution.
the problem goes away if you say that you have to give non-zero support to every project, basically. I'm not sure this is a good solution because, you know, what does it mean if there's a if you really feel that there are 2 projects and this one should be supported and then this one definitely should not be supported, you don't get to express your opinion. So anyway, this I agree that the whole problem is with zeros. So obviously the problem goes away if you say that the vote has to have full support. Then the problem goes away. Yeah. Okay. So this was EPT. So now here I'll skip one more attempt. And so what we finally arrive at is something we call weighted convex combinations, but somehow it looks to me natural, and I suppose that must have come up somewhere, but we didn't find anything. So the idea, the intuition behind it is, I want to be proportional to the delegate to the degree of their support for the bundle, right? So if they give little support to the bundle, I don't care so much about their opinion. Whereas if they give a lot of support to the bundle, then I see that they're somehow committed to these projects. They maybe, you know, thought about it a lot, and then I'll take their opinion seriously. So that's the idea. And now, if you write out the formula, it looks kind of hairy, but it's not complicated at all. So we will say that my vote XVS, so my vote with respect to this bundle, is proportional if it equals the following formula: my default plus the vote of the delegate weighted by the weight. And now you have to normalize this, which is the denominator, and now you multiply it by my budget so that the result actually sums up to my budget. But basically, I'm mixing my default and the vote of the delegate. And if the vote of the delegate is very small compared to my default, then basically my default will override it, mostly. Whereas if they give a lot of support, or I give a lot of weight to the delegate, I have a lot of confidence in this delegate, then their vote will mostly override my default. Right? So you basically have 2 points, my default and their vote, and now you're taking a point on the line between these 2, and you are getting closer and closer to my default as their support decreases, and you're getting closer and closer to them as their support increases either, or you're getting closer to them if you give more weight to them. Right? Yes? For the bundle. So that's a set of projects. So S is, for example, educational projects. Yeah. So the weight and the weight and the threshold, we're thinking of it the same way. It's just that. So for me, the weight is like confidence. Okay. And so if I have a lot of confidence, so if weight is large, then my threshold should be small. So anyway, the thresholds from before are the same thing as the weights, just 1 over. It wasn't a part of, yes, it wasn't a part of the UI. Yeah. And so you can imagine kind of adding another slider, but probably, yeah, okay, so you can add another slider, but it's also possible to somehow like set a reasonable value for this. So the value probably, the reasonable value for this probably wouldn't be 1, but something like number of projects or something like this. And then you can have, you know, an advanced tab or some, you know, so you can allow the voter to adjust this, but maybe not to mess up the UI. You would set a reasonable default value for the weight. Say again? Oh, with 0. Yeah, exactly. So exactly. Yeah. Thank you for the question. So this means, okay, this is to me natural, precisely because if the delegate gives 0, then it simply means that I'm playing my default. Exactly, right? There's a sum of 2 terms, and the second term vanishes, and it means that I'm just playing my default. Right? Yes. Okay, so if the delegate puts a 0 on one project in the bundle, this is completely fine. That's not an issue in either of the approaches. The problem is only if the delegate gives a 0. No, it will resolve to 0 if also my default has a 0. Right? So my solution will be a mixing of the default and the delegate's solution. So if the delegate gives a 0 and I give a 0, the mixing of it will be a 0. If I give a non-zero and the delegate gives a 0, then it will be some number between my default and the delegate, which depends on basically the delegation weight. Yeah. Thanks. Any other questions? Okay. So this is somehow nice because not only can delegations always be resolved, we can show this, but also this function is continuous, it has nice derivatives, and the solutions are described by a quadratic program. This will become important later. But basically it has some, it is nicer in some specific quantifiable ways from the EP approach. Okay, so you can view all this through a game theoretical lens, like this. So you can think of the voters as players, right? And the voters look at, this is what the program would do. They don't literally look at that. They don't have that information when they vote. But the voting system, software, what it would do after everyone has cast their vote, and now by vote I mean this thing which also includes delegations and so on. So the system would look at all the other voters, right? And based on all the other voters, I have a best response function which says what I should play, what my vote should be, if I am to be proportional. So this is exactly, you know, this formula. So you can see that the right-hand side of the formula only depends on the delegate. So if I take my vote over all the projects, it depends on all my delegates. And it exactly says what I should play to be happy, what I should play to consider my vote to be proportional. So this is a best response function. And then you can define my regret with respect to the the current vote, right? So there's some current vote of what I'm doing and what the others are doing, and my regret is just the distance between what I would like to be doing and what I'm actually doing. Yeah? And because the best response function is continuous, you can check it by staring at this. So it's continuous, and now you take the distance, that's also continuous, so the regret function is continuous. And so if I have a function f which is continuous and it's defined on a compact set, so actually what I'm thinking about is a Cartesian product of n m-dimensional simplices. So the set of actions of each player is an m-dimensional simplex, and I have n players. So actually the table, the matrix of votes comes from this space, just the product of n simplices. So this is a compact set, and so I have a function f from this to the same set, it's continuous, and Brouwer's theorem says that f has a fixed point. Right? There's a point x such that x equals f of x. Yeah? And this is why I know that regardless of what the votes are, what the delegations and defaults and whatnot, regardless of what these are, there is a completion of the votes which respects the delegations. This is how you can also prove the result for exact proportionality, except you have to use a stronger theorem by Koutecký, because the function f is actually not a function but a correspondence. You have to allow anything to happen at zeros, and so it's not a function, it's a correspondence, and you have to use a slightly stronger theorem, but it's the same thing. It's you have to use some fixed point theorem. So this is just how you prove, you can see that the conditions of this theorem are very mild. So you don't have to do any work besides check continuity and that we're on a compact set, and you're done. So this part is easy. Exactly. That's the whole point. That's the whole point, right? So yeah. So because my my vote is that I have some information maybe on some projects, I vote directly, and then I have these bundles, I say how much support I want to give to a bundle and who I delegate to. And then this guy delegates to someone else, and that guy delegates to someone else, that guy delegates to me. So I have a delegation cycle. And this means that there's a game where each player has an action space, that's the simplex, and each player has a best response function, which is, if I knew what the others are playing, this is what I would like to play, and then I would be happy completely, right? And this best response function, that's the FV. And now if you take if you take all these functions across the voters, that's the function f. That's also continuous. And now Brouwer tells you that there is a fixed point. And the fixed point is just, so why is this resolving the delegations? It's a point x such that f of x equals x. And what this means that I'm already playing what I want to be playing. In other words, because I have defined regret as xv minus my best response function, and xv equals fv x minus v, this is 0. So my regret is 0, so I'm already proportional. Yeah? So, yes? No, it means that it resolves. Yeah. It actually resolves. It means, okay, so what does it mean that it resolves? A fixed point is a completion of all the votes which respects proportionality. So it's a resolution of the delegation cycles which exactly satisfies this equality. Make sense? Okay. So so now we tried to also tap into the literature on games, but actually I was surprised. It turns out that the literature on games where your action space is an infinite set, is a continuous set, is not as large as I thought. So there, there are things where there are software packages that looked like they might be helpful, but actually they only work for finite games. And anyway, but okay, so you can think of this also as a game, and you can think of the why do delegations resolve? Well, because they're a Nash equilibrium, right? An equilibrium is you're playing an action that you cannot improve. Nobody can improve, and here you can see that if I am not proportional, if my vote is not proportional, then by my unilateral action, I could always decrease my regret, right? And because there is a solution where nobody can decrease their regret, that means that there must be a solution where everyone's regret is 0. So you can also, this delegation resolution result, you can just view it as the existence of Nash equilibria. So this is exactly what we would like to know, right? So we know that this is not the direction. If something can be cast as finding Nash equilibria, it doesn't yet mean that it must be hard.
No, but if it can be cast as a certain type of a fixed point,
yes,
then it is PLS complete.
I don't see that. I would like to understand that. So, I could create a, there are fixed points. For example, if your function is a contraction, then you can actually find the fixed point quickly. So the finding of, finding fixed points is not hard is not hard in all cases. There exist cases when it's hard. So, okay, so this is thank you for pointing that out. This is probably my biggest question about this thing, which is finding these fixed points hard? And I strongly suspect that it should be, and that the only reason why we didn't show this is that neither of us co-authors has any experience with these types of reductions. So, if any of you has and is interested in this, we would be very happy to show that this is PLS complete, or even, if you could show that it's PPAT complete or something like this. It definitely smells like it should be hard. But we haven't shown that yet. Okay. So now, exactly, we are interested in complexity, right? So we don't know hardness yet, but I think there actually is an interesting result. This is not technically difficult, but I think it's actually interesting. So if n and m are small number of voters and number of projects is small, you can use the existential theory of the reals. What this means is if you have a sentence of logical sentence of polynomials, of polynomial equalities, inequalities, and so on, and you're asking, is there an assignment to these polynomial inequalities? Yes or no? Okay. This problem can be decided in polynomial time if the number of variables and the degrees of the polynomials are fixed. Okay? One has to be careful. I'm not saying that the assignment satisfying this can be found, because the assignment satisfying this can be irrational easily, right? But the existence can be decided. So that's useless here because we already know that it exists. But of course, you can then do some easy technical tricks where you basically do binary search over the variables, and so you can find a point which is arbitrarily close to the fixed point. Okay, so if you give me an epsilon, I can find a point which is epsilon close to the fixed point in time something ugly in terms of n and m, and logarithmic in 1 over epsilon. Okay, by repeatedly solving this decision problem. That's not that interesting, but so there's stuff from logic that you can apply. Maybe you're asking what are the polynomials, right? So here I want to basically encode this inequality. The denominator is a linear term. It looks like a 1 norm, but it's actually not 1 norm because everything is non-negative. So it's just a sum of things. And so if you multiply both sides by the denominator, what you get is a quadratic term on the left and a linear term on the right. And that's so you can describe the set of solutions, the set of fixed points, by quadratic equality constraints. And then you add in the simplex constraints that, you know, the action spaces are these simplices, and that describes the set. And you're just asking, does there exist something in this, or, you know, find something in this? So, so yes, this can be described by a logical sentence with quadratic polynomials, and the number of variables is just n times m, and then the dependence on the numbers involved is logarithmic. So, you know, there are some constants involved, the defaults and the weights and so on, but the dependence on these numbers is also nice. So nothing breaks there. So if you got lost in the details, what I'm saying is, if there's few voters and few candidates, in theory, this can be solved efficiently. Okay, so Jakub is saying that if the system was homogeneous, that it would be n by n. Then under some conditions you could have a linear algorithm. Would like your guess at what the conditions would be?
No, but I don't have a good feel for what does it mean to have the sort of the same number of constraints. Variables. But
Right.
and there are some ways to make things homogeneous. Then it gets hairy.
Okay. So here I think even like having it n by n would not necessarily make it homogeneous, because the constraints are, you have one constraint for every delegation, right? And the delegations are in terms of the bundles. So for example, if everyone just voted directly, then there are no constraints and no variables, right? So probably homogeneous and the number of voters, number of candidates are not related in a simple way, but okay, so let's get back to that later. What we can show is, again, this is a simple observation, but I think it could be useful in practice, because you can expect that the structure of the election would be something like that you have some kind of top-level experts, which are people that everybody knows about, and these maybe form some cycles, but there's not that many of these experts. And then maybe you have like regional or domain experts who delegate within each other, and they delegate to the top-level experts, but maybe on topics like, if you have some topics in Bohemia and some topics in Moravia, you don't have people forming a delegation cycles on regional topics or something like that. And so maybe the graph, the delegation graph, is large, but maybe it's almost a DAG in the sense that the strongly connected components are small. Okay? If this is true, you can again just process it starting from the sync components and working backward, right? Because the top level experts only delegate to each other. So in order to complete their votes, it's enough to just consider them. So if the number of projects is small and the number of these top level experts is small, you can solve the quadratic program, the small quadratic program corresponding to these. That fixes their votes. And now you can move on to the regional experts. And what they depend on, the top level experts, this has already been resolved, so these are just constants. Okay? So basically, by doing this, so we're combining just standard, I guess you can call it dynamic programming on a DAG, with this applying existential theory of the reals to get an algorithm which solves this problem in time which has an ugly dependence, not on the number of voters and candidates, but on the size of the largest strongly connected component. And one can imagine that in the real-world instances, this would be small, even though the instance overall is large. I'm brushing some details under the rug here. Specifically, the size of the strongly connected component is not just the number of voters delegating to each other. Actually, the graph should be that there is a node for every voter and every project, or every voter and every candidate. And there's an edge if my decision on this, or the decision on this voter and candidate, depends on this voter and this delegate and their candidate. So the graph would be larger than just voters, and then the dependency is actually on the strongly connected component of this graph. But let's say that that's just a detail. Okay, now briefly about some extensions and other applications. So another problem that you can model with this is media content and like campaigning in media content. So if you take TV time, you can think of this as a cumulative ballot because there's 24 hours of programming that you have to split. There's not more than 24 hours. And something that I have noticed or realized, which is also kind of obvious, is that in a way, stations are forced to cover what other stations cover. So there was recently some kind of a town hall program with Trump on CNN. And because CNN decided to give Trump this time, now everyone has to comment on that. So they decided to do a program, and maybe there was a station that wouldn't talk about Trump if this didn't happen, but now Trump has said a bunch of things, and now you have to invite other people to say a bunch of things about what Trump has said, and so on. So this is actually the same kind of thing where the station has, you can think of the candidates as topics. So how much topic do you, how much time you do spend on Trump, and how much time do you spend on climate change, and how much time do you spend on immigration? And in a way, the decision of this TV station depends on the decision of other stations. And it's also imaginable that this forms a cycle, right? The delegation would probably not be straightforward, but you can imagine that it could be continuous. And so, and also you can imagine that the same thing I showed here with the DAG, with the delegation graph, happens here. So you have top-tier stations, and these influence regional specific stations and domain specific stations, but they don't influence the top-level stations. Or there are bloggers, and the bloggers talk about what the TV stations talk about, but not vice versa. And so you can ask the question, how does this really work? But more interestingly, you can solve the campaigning problem. So the campaigning problem would be something like, what's the cheapest change to programming such that the new equilibrium, the new resolution to the delegations, is favorable for me in some well-defined way? And now this can again be defined by polynomial constraints and some polynomial objective. And so if your delegation graph has these small, strongly connected components, you can also solve this campaigning problem, which is kind of a variant of a problem which is very prominent in computational social choice. So in computational social choice, a prominent problem is bribery, which is you have a set of voters, and now how should you influence them so that you minimize the cost and your candidate becomes the winner. And this has many flavors, depending on what kind of bribery actions you allow, what is the voting rule which resolves the election, and so on. So this is a form of a bribery problem where the ballots are cumulative ballots, and there is some form of like opinion diffusion going on. Also, you can consider other types of delegations. I introduced this exact proportionality rule and the weighted convex combinations rule. So you can also decide to delegate one bundle using EP and another bundle using this weighted convex combinations or even something else. You can use subcommittees. So I explained that the weighted convex combination approach says here's my default and here's the expert, and now you're choosing something on the line. You can designate multiple experts, right? And that will give you, the convex hull of these will give you some polytope, and now you're choosing some point within this polytope, and which point you choose depends on the weights and the supports of the delegates. So you could delegate to multiple people and kind of say, I want a mix of their opinions. I think that, all of these people know something about education, and I want a mix of their opinions. You can also do this. Also, so far, we kind of assume that in participatory budgeting, what people would do is like they would choose domain experts. So they would make the high-level decision of how much money do I spend on education, and they would delegate the small-level decision on which projects to split it on. But you can also reverse it. So you can say, like, between these projects, I would like the ratios to be like this, but I'm not really sure how much to give to education, and I delegate the large-level decision to someone else. That would still be a continuous function, and everything would hold. You can think about the continuous functions as more complicated than just these weights that I had, and then you can also apply all of this to spatial voting. So spatial voting is basically a generalization of these cumulative ballots. So cumulative ballots are, you're choosing a point from a simplex. You need to have a vector which sums up to 1. In spatial voting, you can think of it as you have the candidates are products, and you're giving stars to the products, right? So in each dimension, it's a number between 0 and 5, for example. Or it could be between 1 and -1, how much you like or hate something. So just where spatial voting is the idea that a vote is a point in space, in general, m-dimensional space. So you can apply this idea of delegations and liquid democracy to spatial voting, and essentially everything that I said still works. So those are some ideas, and I would be happy for any questions, any feedback. Thank you for having me. And they want to use the mic for the discussion, so yes.
Hello, thanks. The interesting thing about this is that it's not about voting, I think. You mentioned some examples where you can use it as a modeling framework, right, about some problems. Could you maybe go back to the media coverage?
Yes.
And tell me what should be the output of this example when you apply the framework?
Right. So here, I think really I'm thinking about the campaigning problem. So, it's not like a TV station has a formula where like they apply the formula and say, okay, because CNN is spending so much time on this, we need to spend so much time on that. But if you're a campaigner, you will just model this phenomenon in some way. So you will decide that probably there's a linear dependency or a quadratic dependency or something. So you will come up with some model of how the stations influence each other. And now you're interested in the campaigning problem. So you're asking which stations should I influence to get the most benefit for my candidate. So basically, in practice, it would mean that you do some sociological and media research. Also, you need to estimate how difficult or easy it would be for you to shift some station in some direction. So, can I get airtime at CNN or can I get airtime at Fox or something? This would give you some costs to your cost function. And now you can solve this problem, and that would kind of tell you what should be the action that you would do. Now, anytime I speak on this topic, I need to explain why we're interested in doing these evil things. And basically, my answer, there's not a the answer, but my answer is the evil guys are doing it anyway. So we need to understand how this works. Also, you don't have to do the action, but you can use it to kind of analyze what's going on, or what they would do. So you could come up with a model of how media works and how people influence each other and so on, and then you can ask, what would the Russians do, right? And this might give you an answer, and it might allow you to anticipate and maybe defend against an attack on democracy or on the media space. So that's just an aside for like why one would be interested in this problem. So here, kind of each station would have a like their current action of what they are doing, and you are asking, how can I deviate them as little as possible so that after this process resolves, I get a desired outcome. Have I answered your question?
Yeah, I think so. Thank you.
Right, so my favorite topic of the iterated function systems. So I think that you won't be sort of too surprised with the sort of extension that actually there is some stochastic process which tells you how important the events are at this point in time, right? Which is unknown to you. And that sort of drives some of what the TV stations are reporting, right? So if you bomb a certain place or such like, you sort of gain the attention of everyone, and the share of the sort of airtime will go to this bombing or whatever sort of important event. And then the rest of the airtime gets split into Prince Harry's interview with someone famous and the Trump town hall and such like, which then gets amplified in this fashion, right? And so sort of maybe an interesting extension would be to sort of model this sort of uncertainty in how much of this primary content will the stations have to present, and how much of this secondary amplification will be going on. And then the Russians can actually influence the primary content as well by doing something very gruesome. Okay. Or they can sort of play with the amplification part only. And, right. But I think that the uncertainty is an important component in some of this, right? Like when you have the voting, reasoning about the uncertainty maybe is not as important, but I think that in the media, the uncertainty is substantial. Right. I think that assuming that everything is deterministic in here is not a great assumption. Yes. But we could do that, as a sort of a unique invariant measures and weak convergence and that stuff. Right. So I would be interested in how one would kind of model this reasonably. That's kind of my question overall. And kind of my thesis here is that this is a model which is rich enough to model reality in a non-trivial way,
and it's still efficient in some meaningful sense. You know, as long as the delegation forms small pockets, then you can resolve it, because the small pockets would be hard to solve, but because they're small, it should be feasible, and then you can work backwards. So, so this is a new model, right? And so what I'm asking is, how can you come up with a model which also captures some uncertainty without sacrificing that you can say something about it?
With Arash, we actually have a sort of a draft on shaping the unique invariant measure in this IFS sort of a setting, which would be a lot like your campaigning problem. So
Okay.
sort of you want to influence the shape of what you end up with, like your
Yes.
resolution,
Yes.
and do it in this sort of a model with the uncertainty.
Yeah.
We haven't not finished it. It's not that easy, but we would be happy to share what we have or
Yeah.
such.
Oh, excellent, excellent talk. Thank you so much. Just I wanted to ask a mathematics note. I wanted to know each delegate is a player, yeah?
Yes.
Is it, yeah.
So each delegate is a voter like anyone else. So there are just voters. They're like, you know, when I use the word expert, it's because likely there are people who will get many delegations, and likely most people will not get any delegations. But this is not a feature of the model. In the model, all voters are equal.
Yeah, each delegate likes to place the best action to get the best response to each player around of, for example, one player. Yeah.
No. Okay.
No?
So I think what you okay. So if I knew that people are delegating to me, right?
Yeah.
Then I knew I could kind of ask the question, how could I use my influence as best as possible? So this is also a question we got asked, and so it's not a part of our answer. We don't know. So I don't even know how to ask this question. Well yet. What I know is, in order to consider this question, you would also need to consider a voting rule. Okay. So what we describe here is basically just a vote elicitation process, right? If you think about the participatory budgeting example, what you get on input are some incomplete votes, and what we describe is how to complete the votes, but this is not the voting rule. The voting rule is the mechanism which says which projects to support and which projects to not support. If you wanted to ask kind of what should a delegate do, or what should a voter do to maximize their, or like to maximize their utility, their outcome, then you need to define what is the voting rule we're considering, because only the voting rule gives you the outcome, not the ballots themselves. So we think that this is a legitimate question, but what we are saying does not address the question.
Yeah, but I mean, I wanted to ask, correspond to each delegate, we made a best response function, yeah, and then
So
we
sorry.
made
So the best response function is defined for a voter with respect to his delegate.
Sure.
So it's not the way you should think of it is that you as a voter are delegating to something, to someone, and now if you learned what they are doing, the best response function defines what you should be doing in order to be proportionate to them, not what you as a delegate should do in order to get them to vote in a certain way. Can you see the distinction?
Yeah, but what guarantees for the best regret function you made by each delegate?
Say again?
I mean, is there any guarantee for the best minimization of regret function. Yeah. You made a regret
Yes.
correspond to each
Best response.
delegate. Yeah, the best response. Yeah.
Each voter. So each
Yeah,
voter has a regret function,
Yeah.
and the regret function is how far is my current vote from my desired vote, from my best response. That's the regret,
Yeah.
right? And what we show is that there is a solution which makes everyone's regret 0.
Yeah. Yeah.
Is
Yeah. I got it. Yeah.
yeah?
Yeah.
Okay.
Yeah. Okay. Thanks.
But we don't know how to find it.
Yeah.
Any more questions? If not, then let's thank the speaker again.
Okay, thank you. Já bych tak rád, já jsem teďka víc na Zoomu než osobně, protože máme miminko, ale